can authorize my reader to read all cards and to write all cards. This, of course, makes everything so much easier because I can just use the actual commercial reader with the actual commercial software and just use my emulated IM to authorize this reader to do whatever I want. And I don't need to write any user interface for my card writer. That's why my card writer is just proof of concept. I don't have a really nice interface for my card writer because I'm just using the Windows software. As going further for the master token contents, playing with it and referring to the Chinese document, byte 7 contains what in Legic terms is the WRP and WRC. We're going to see that a little bit later. And also the read protection, which isn't very useful on master tokens, so it's not being used. Byte 5 is the token type. There are some values. If you have any value in this range, you'll get an IAM. If you have any value in this range, you have got a SAM. And any value in this range, you've got a GAM. And the uppermost bit is organization level enable, which is a separate bit that authorizes your token to create subtokens. I'm not sure this is exposed in the official Legic software, but you can, for example, have a GAM that cannot create subtokens, which is completely useless. And you can have an IAM that can create subtokens, which is kind of more useful. Byte 6, I haven't completely figured out what these special values mean, but you must set it to FC minus the stamp length, and if you do that, you're fine, and you're not going to crash the software, at least most of the time. With this, now I can create my own GAM, which I have in simulation as well as in physical. I've used the failed attempt at creating an IAM previously and just turned it into a GAM. Now I have my only GAM for 5 bad code, which is a stamp that hopefully nobody uses in real life, so it's not a big problem if somebody steals this from me. I didn't want to use any other stamp for this reason. With what I know now, I can create IAMs and SAMs for arbitrary stamp lengths, including 0. Of course, the stamp must have some length if you want to launch a reader with it. And the IAM with stamp length 0 can authorize read and write access to arbitrary cards. I can create GAMs with stamp length 0, but the software won't accept them. It just sits there for 2 seconds, ponders the virtue of its existence or whatever, and then pretends that the card is empty without any error message. So there seems to be a conscious lockout, the origin of which I'm not completely sure about. Now we'll try to look into the card contents themselves, which turn out to present 1 or 2 additional what the fucks. As I said before, for some of the cards where there is Windows software available that will read the card, if you have a proper master token, you can just use the über-IAM to authorize your software to read the card, so you don't need to reverse engineer it anymore. Otherwise, there might be, there's a standard segment definition format available that you can use to understand the card format. And even if that isn't available, such as for the Mensa in München, I think, you can just look at the raw card contents that you'll get from your reader. Turns out they are obfuscated. Who would have thought? All the card payload is XORed with some byte, with some value, some very secret value, which is the CRC of the UID. This is the principle I'm going to call obscurity in depth. It's not security or defense in depth, it's obscurity in depth. Yeah, this is the card format. I'm not going into all the details here, just that you see there's the UID, the decremental field. Here are some values which are either fixed or don't care. I believe this has something to do with the distinction between segmented and unsegmented cards. In ancient times, like 10 years ago, there were unsegmented cards which nobody uses anymore. And apparently, if you have the wrong bytes set here, you have an unsegmented cards, but all the newer cards are segmented and the payload starts at byte 22. Funny thing is that I've only been talking about the MIM 256 and MIM 1024. There's actually a third card type, MIM 22, which is just this area. So 22 bytes is enough for a master token and probably the original card format. And it's unsegmented by definition, obviously. Within this payload, there are all the segments that you have defined on your card, one after another. I'm going into small details after that. And before that, there's some backup area. It turns out they have a nice backup strategy. Before writing any of the segment headers, they are copying the segment header out of the obfuscated area into the clear text area. And make a backup copy with a dirty bit so that if the update of the segment header fails, the backup copy is still there so that you can restore the original header later on. I'm not going into all of the details. You can look it up on the slides later. One of the things that I want to turn your attention to is that there's a flag field. One of the flags is last segment. That's not as important. The other flag is not deleted or valid. So if this flag is set, it's a valid segment, and if it's not set, it's a deleted segment. So deletion of a segment doesn't actually delete the data, but only sets a flag in the header. That's why my card reader can read deleted segments. And one of these bytes is the WRP. Since these are only interpreted on the reader and don't actually do anything, I'm not entirely sure what these should do, but WRP seems to be write protection. Always includes the stamp and is something like the first so and so many bytes of the segment are write protected. For example, on the Mensa card, you have the card number in this area, so the reader, even if it's instructed to, it won't write to this area. Of course, my reader will. Also, in this byte or the next byte, there is the read protection we've heard so much about. If this bit is set, the segment is read protected. If it's not set, it's free to read for anybody, but since my reader doesn't care, you can read protected segments with my reader. Yeah, that's basically what we are going to tell you, at least at this point. As I said, we are not going to release any attack tools, so please don't ask. We have released a demonstration tool that you can use to read cards, and hopefully that will convince you and your bosses that this card type isn't secure anymore. The root security issues that we found is that no encryption, no keys, which also means there's no key management, no card authentication, no reader authentication, which easily enables spoofing and skimming. That's one of the big problems of this card type, which is why this problem is even worse than with MIFARE Classic. With MIFARE Classic, the read distance was given at 10 centimeters, and that was optimistic. For Legic Prime, the vendor claims a read distance of up to 70 centimeters with ordinary hardware. And as I said, you can use an Uber-EAM to use a commercial 70 centimeter reader to just read any card. And since the card is not read protected at all, you can just clone cards over a distance of 70 centimeters. One of the other issues that follows from no key management is that you can create segments out of thin air and you can create master tokens out of thin air without knowing anything but the stamp. A more subtle problem is that there's no authentication necessary for the use of those master tokens, which kind of counteracts what they are claiming on their website. On their website, they claim that a master token cannot be copied. And basically in the same sentence, they'll tell you how to use a master token. You use a master token by just putting it onto the reader and then taking it away and maybe put it into the safe. And after that, the reader can create cards for 10 minutes. But it doesn't need the actual master token anymore. So you have created a copy. It's a temporary copy in the reader with a timeout of 10 minutes. But if you just create a card every 5 minutes, the timeout will reset and you have a copy that will last indefinitely. Which means the master tokens are inherently clonable. Yeah, as we've seen, the Proxmark is a really great tool for pen testing and reverse engineering and basically everything. We have released the